For the apparatus, we used sticks and a funnel with an empty pen attached to it, cardboard with a hole, and we insert the funnel inside it, A3 size graph paper, and some other equipment such as ruler, engineering ruler, and scissors. We used sieve to filter the sand to make it smooth enough to flow consistently, and we used tape to attach the sticks and the other pieces together to create the final apparatus.
We've set the apparatus while holding the engineering ruler so that we can measure the height of the pile. Moreover, we also put a graph paper under the pile so that we can measure the diameter. To measure the diameter with the height at the exact time, we've recorded the experiment from two sides with the time as shown in the video. The first side is to measure the height and the second is for the diameter.
Also, we mark the point where the sand will initially fall.
As you can see here, we pause the video at every 1 centimeter increments of height so that we can observe the time at that particular height as well as the diameter.
In the latter part of the experiment, the sand added to the pile doesn't increase the height much, instead it increases the diameter more. This is explored more later on in the video when we establish the relationship between height and time. This is the results obtained from performing the experiment. As you can see, we have the data of every 1 centimeter increments of height. In addition, we found the ratio between diameter and height for each 1 centimeter increments. Then we found the average. Also, we calculated the flow rate of sand by using the formula volume over time. We converted the volume formula of cone from pi r square h of all over 3 to pi d square h all over 12. Then we calculated the flow rate for each 1 centimeter increments. Then we found the average flow rate, which is 1.585 centimeter cube over seconds. The relationship between the height and time is obviously direct, where height increases as time does. In the beginning phases of the experiment, the growth of height was very rapid as time went on. However, in the latter phases, the growth of height was drastically slowed down. This behavior demonstrates the logarithmic growth.
In the first prototype, one of the most prominent mistakes we made was the way we hung the bottle, namely the flimsy attachment using string and tape and its incorrect alignment. Additionally, we used a non-engineering ruler and didn't even secure the stick feet properly. In the second prototype, we managed to secure the bottle between the stick using rope in a sturdy and straight manner. We also tapped the feet to secure them from sliding.
Prototype 2 failed because we didn't use engineering ruler. Also, the bottle wasn't as dependable as the funnel in terms of constantly flowing sand through the pen. Moreover, We didn't filter the sand, so there was impurities and irregularities in the sand. Nevertheless, the angle of filming wasn't even correct, so we couldn't take right measurements from the video. These mistakes were necessary obstacles in the learning process, which led us to gain the required experience to successfully construct the apparatus.